I want to know about the potential of data centers in space. It sounds like a crazy idea. I know some folks are working on it. Just kind of like, what's your high level take of the progress we've been tracking? Dollar per kilo to orbit. It's been falling, but recently there's been setbacks in different programs, and there's more competition, and there's a lot of different dynamics going on. What do you think the key milestones are to get us to a future where we're really doing, mass manufacturing, big, mega scale projects in space?
Yeah, well, let me start off. I mean, I think you guys are hitting on the right metric, right? It's like the hardest part of this is what does it cost to get a kilogram in space? Because everything else kind of derives from that. Ultimately, if you want a certain amount of power, if you want to be able to put an aperture in space to do communications, whatever it is, like that's really driven by what it costs to get it there in the first place. And I think it's important context to kind of see how far we've come down that path. I mean, largely driven by SpaceX over the last decade. And I like to tell the story of, about 15 years ago at Skybox when we were trying to launch these small satellites. We were literally going to Southeast Russia and launching satellites on converted Russian ICBMs. I mean, they were popping out of the ground and putting satellites into space. That was the only way for like a Silicon Valley venture funded startup to go put something in space.
Wait, hold on. Did I hear you correctly? Like the ICBM actually launches from one of those missile silos in the ground and makes it to orbit?
Pops out of the ground and goes to orbit. I mean, there's videos on YouTube.
That's crazy.
If you search the NEPR on YouTube, you can see this, and it's crazy. I mean, and that's what it took before SpaceX kind of like revolutionized the launch business.
Wow. Yeah.
And even at that, we were spending something like 10 times as much per satellite or per kilo is what we can go buy on a transporter launch today. So there's been at least one and arguably two orders of magnitude improvement in the last, call it decade, on kind of what it means to launch things to orbit. I think if you imagine that happening again, another order of magnitude, again, it's going to dramatically change the way you think about feasibility of some of these things, like putting very, very large power hungry things in orbit. We know how to do the solar, we know how to do the structures, we know how to get, we know how to make electronics work in the radiation environment, which is always a concern, and do it reliably. And so really, ultimately, I think it's going to come down to unit cost and what does it actually take to do that. The great thing about space is you have virtually limitless power. The sun, you can go into orbits where you're in the sun all the time. So it's not like solar on Earth where you're going in and out of eclipse or in and out of night. Like you can be on all the time. And then you have this cosmic background of 3 Kelvin cold sink that you can go dissipate all the thermal energy you need from running your electronics and stuff. So it's actually in a lot of ways like sort of an ideal environment to do this if you can actually get there. So that's the kind of way I think about it.